I'm actually, yeah, it's been great. Just for the first few hours, it's been great hanging on the Discord. I'm really amazed about how much people have interacted, which is great. I think that was the point of the reading group, to help each other. But yeah, since I'm here today, I prepared some. Yeah, that's like I just did it on a text editor to make things simple for me, mostly. So this is what I got from the people in the Discord, things which I thought would be interesting to talk about. Uh, by the way, my idea is also that if you look in your Zoom window, yeah, you should. Let me open it for myself too. You should see a question and answers button, and it would be great if you have questions along the session that you type them there, because that makes also easier for me to know which questions you have. So the idea is that I will try to go. I'll try to go uh, talking about all of these topics. And then if you have questions about the topic we are talking, just write it down in the questions and answers in Zoom. And apart from that, at the end we can just have a chat about any other things you want. So I think that would be roughly the outline. So uh, some of these questions are going to be might be longer. Some of those might be shorter, but well, that's how it is. So I think that the best thing is I start, and actually the first question we got, and I think that's something. There's been a lot of discussion in chapter 2, has been, well, how does all of project management work in Haskell? Because well, this is always a hard thing when you start in a new ecosystem. You have like the tools and the repositories and the place where you have the dependencies and the files and so on. And Haskell is actually quite opinionated on the one hand about the naming, but also we have this beautiful / terrible thing of having two competing build tools, which, these competitions have made them grow, but that also means that sometimes you need to make a choice. So I made a rough, I took all my ASCII art abilities to create this kind of relation between concepts and my goal is that you understand what's the relation between these ideas and where you write it down, because each of these things are in different files. So I think the best is to start with a package. So a package is like the unit of distribution, and that's what you write in your Cabal file. So your Cabal file defines a package, and those are also the things you depend on. So if you want to depend on what we say a library, this library is actually in a package, and what you usually do is you write a Cabal file in which defines your own package, and there you depend on other packages. So I have an example here from a project I have where this is the Cabal file, and I have like the name of the package is going to be this one, and then packages can have different libraries and different executables, but the point is that you depend on other packages, and these are the packages I'm depending on. So here I'm depending on Liquid Haskell, here I'm depending on base, which is the base library, and on this other package, and so on. Now, the question is, where do those packages come from? So your dependency often come from a repository, and in the Haskell ecosystem, we have Hackage and Stackage, and that's essentially a repository for your packages. So I don't know, that's similar to like Maven repo if you are doing JVM programming, or something like npm if you are doing it's the npm repository if you're doing JavaScript, things like that. So the bare minimum you need to be able to build a package, to build a package is the Cabal file, which defines the package, and then you have the dependencies, which live in a repository. Now, to make things a bit harder, actually, you may have what they often call projects, and that's essentially a set of packages. So sometimes you are building several packages together because one depends on the other, things like this, and you want to build all of them at the same time. So you create a project file, and actually, if you're using a stack, and I'll talk about this later, you always need this project file, which is called a stack.yaml. If you're using Cabal, you optionally can have the cabal.project, and that defines what are, as I say, the packages in your project. So you have to think like the project is the thing you are working on, and they have one or more packages, and then you have the repository, which is the things out there, and you depend on those things. As I said, the package are defined on a Cabal file, and packages are made out of modules, and modules are the files right. So those are the things you actually compile and the things you import. And what it's important is that in both Cabal and Stack, the name of the module has to coincide with the path and to the file. So, for example, here I have my example here. So I say, okay, this library GADT, that's name, it's not important. It's in this source directory and has one module called example. So what Cabal will expect is that you go into this source directory, so you see source GADT, and then the module has the name example. If now I want to have another module called I don't know, Haskell.Amsterdam, then I expect to have a new folder called Haskell, and then have a file called Amsterdam.hs. So you have to remember, and then you will have to start your module with module Haskell.Amsterdam where. So that's essentially how what the relation between these things are. I also have I found an old picture I made where you have this. You can also think like essentially you have several packages like your project, and packages are made of modules. So when you depend, your project depends on several other packages, but your modules import other modules. So the small things import the small thing. Now, that's like the general picture. Something which a lot of people struggle with is this idea that we have Hackage and Stackage, and they have like similar names, but they are slightly different. So what is the difference between those? So essentially, Hackage is like, it's like an anarchistic place where everybody can upload the packages and versions. Of course, I mean, once you upload the package, you're the only one which can upload a new version of it. But everybody can freely do it, and there are packages there which are not maintained at all for a decade, which means that incompatibilities may arise between those. So it might come to a point where you try to use a package and it requires a version of a dependency which is incompatible with something else. So that's the problem. And there is like a package versioning policy, which is something similar to semantic versioning, which attempt to minimize breakage. But the point is that Hackage is essentially free, so you have no warranties of things working with respect to versioning. So some people came with the idea of a stackage, which essentially is taking Hackage and organizing the packages in resolvers, and each resolver essentially is a fixed version of everything. So you say, for example, I'm using resolver 15.16, they have like versions, and then that means I'm using GHC version 8.8 and Cabal 3.2 and these versions of packages, which are known to build. And the nice thing is that There is a CI pipeline which builds them and ensures that they build together. The drawback is you have fewer available packages because they have to be known to build together, but you can complement them with Hackage. So knowing what the repositories are, let me talk a bit about the project file, which are, as I mentioned, the Cabal project or the stack.yaml. And essentially, in both cases, you specify one or more projects to build, and you can also specify additional sources of dependencies. So stack.yaml is mandatory if you use stack, and the default source of packages is going to be stackage, and you need to specify a resolver, and you have additional sources which you can add. So for example, here, I have my stack.yaml file, and this says, well, my resolver is this nightly blah, blah, blah. That's essentially yesterday's version. And my package is going to be only one, which lives in my root. And I have extra dependencies, which by default, these extra dependencies are coming from Hackage. So these are things which are not in the stackage. So I want them from Hackage. And you can even say, I want this from a Git commit. So that's also something you can do. Cabal.project is a similar thing. So I have both here. And this essentially mentions also the packages, and you can mention the compiler. And by default, it uses Hackage, and you can have also Git as an additional source. So essentially, the workflow usually is like, if you only want to have one package, you either create your Cabal file, and then you create a stack.yaml, which points to the right resolver. If you want to use a stack, if you want to use Cabal, you just need the Cabal file until you need something extra. But the main idea still is where the dependencies are coming from. It's either stackage or Hackage. So yeah, I don't know if there are some more questions about this. So I know it's a bit essentially it's a bit maybe too many moving pieces. My recommendation is I just learn how to use one of the tools, in my case Stock, and then I just use it. So I just go and use the latest resolver you have, and then from time to time I try to update it, and then I know there is there is a question which points to an extra possibility. So which is, do you recommend using HPAC and package.yaml? So actually, I was not completely true. Your package, it's on a Cabal file, but you can also use a package.yaml file. That's something called HPAC. It's essentially an alternative format from Cabal, which has some niceties. Personally, I haven't used HPAC. I have so most people that like to use HPAC, they have big packages which might have a lot of duplicate dependencies, and HPAC is great for that. Personally, Cabal has served me well up to now, so I've gone with that. But other than that, yeah, package.yaml is, as I say, a different way to define your Cabal file. And yeah, so yeah, so I don't lean towards anything. I just don't use it because I haven't seen the need until now to use it. Something which this also goes a bit on one of the questions we had, which is the reproducibility, is that actually if you have a stack YAML file, this essentially means that everybody is sharing the same tool chain and versions. So if you see here, the stack.yaml file defines specifically the resolver, which specifies like the version of the GHC and every package, and any other package actually needs a version. And you can even add here something like add as an SHAs to be able to ensure that you are getting the same dependency. So a stack.yaml is a way to have full reproducibility, and actually that's the reason why I started using it to collaborate with other people's, because you give this and then you know you are always on the same page. And if you want to update things and you update the resolver, you know that everybody will get the same thing. Yeah, and yeah, I'm sorry, I'm reading the chat. Yeah, if you want to do this with Cabal, you can also do this. You can essentially open your terminal, and let me open a terminal, and you run Cabal freeze, and this creates a freeze file which specifies all your versions. So with this, you can put this on your Git repo, and then everybody has the same thing. So it reads the freeze. I don't know if I need to do Cabal and freeze. It's just a thing. No, I just need to remove the thing. So in both cases, you can have full reproducibility. It's just essentially Stack was thought of for reproducibility, so you always get it by default. If you want to use Cabal, then you have to run Cabal freeze. Good. So that was the first question, and I said, yeah, if somebody pops along the way, so somebody wants to say something, that feel free to put it. Another question was, yeah. Oh, sorry. Yeah, some anonymous get hi.yaml from my project. It's a way to modularize my code. So that's actually not the answer. So yeah, somebody has seen the hi.yaml. That's actually an extra. So this hi.yaml is for essentially editor integration. So you can see that I'm using Visual Studio Code, and I'm using this extension which works really well, which is called it's called Haskell. So that's the Haskell support. I fully recommend this. You just download it and it works. But it asks you for one thing, which is if you have several libraries or several things on your Cabal file, there you have to create this file saying where the things are. So essentially, that's an extra thing for editor integration. You often don't need it, so I'm actually doing that's an example project I'm using to show how you can use Liquid Haskell, which is an extension of Haskell. So I'm doing some weird stuff. So I need to help. My editor integration to say where the files are. You don't need this in general, so that's like an extra thing. But yeah, this hi.yaml that's from yeah, I don't know where the hi is. I think it's Haskell information extended or something like this. So yeah. So yeah, but as I said, you often don't see this, and that's only to help my editor. If you just want to run things, or in general, if you want to use Visual Studio Code with Haskell, you don't need to write these things. Good. Okay, let's go to the second question, which, well, sort of the second things I thought was interesting to discuss, because there was some discussion in the Discord. So let me open a new terminal and open GHCI. So the thing is, if I write 1 + 2 here, this works perfectly fine. But sometimes if you do numbers, things like this, suddenly things break, and you need to write something like 1 integer +2 or things like this. So first of all, because not everybody might be aware of this, so in general, you surely know that ... is the way you introduce a type in GHC. So I can say, for example, f has type into int, and then f is +1. So I can write something like this, and now the type of f is into int. But I can also put these type annotations in line. So I could also sort of say f equals +1 of type into int, and that essentially would give me the same type for f. So here comes the trick. So imagine, for example, I'm calling null on empty list. This null essentially tells you whether the list is empty or not, and I'm using an empty list. Now, what happens? The type of the empty list is actually list of A, and if you think about it, I haven't specified what is the type of my empty list in this call to null. So I could have said that my empty list is of type list of int, and it's of type list of bool. It doesn't matter. We're only thinking about the types. So in general, GHC, when it doesn't know what type things should have, it just shouts at you. It says, I don't know what it is. However, it would be very cumbersome to do the things like this for things like, I don't know, null and things like this. So GHCI, the interpreter, comes with what it's called a defaulting rules, which say, okay, essentially, if you have a list and you don't know what it is, assume it's a list of empty tuples, and then things work well. I mean, if there is something else telling you to be a list of int, go with it. But although if you don't know what it is, go with the list of empty tuples, and that's because we want to essentially be able to write things like this. And the same happened with numbers. I actually don't remember if I introduced this before chapter 4, where I introduced type classes, but the thing is that numbers in Haskell have a weird type. So type 1 is not an int, it's not a float, it's actually a polymorphic. It's called a polymorphic literal, an overloaded literal. So it can have different types depending on what you need. And that's because in other languages, what they do is they say, well, one has type. Let me write here. So what they say is one has type int, and then there is a conversion from int to float, which happens implicitly. That's what you would see like in Java, in C, in many languages. But there are no implicit conversions in Haskell, so they have to come out with another idea to say, well, if I write a 1, it should be an int, but it should be a float if I need it, because I don't want to I don't want to have, I mean, int or integer or int32. They're all types, and we want always the literal one to be allowed for all these types. So they come up with this idea of overloaded literals, which means that if I write the type of 1, this is actually not any number. That's actually a literal. So the type says, well, if it can be anything you want, any p you want, given that this p is numeric, implements the num thing. So I could essentially say 1 is an integer. I could also say that 1 is a float, and all of this will work. You see that when it's a float, then it gets printed in another way. And the same happens for rationals, for example. The same happen for things like this. So that's and as I said, that does only happens in the interpreter. This doesn't happen in if you write a file. So the thing is, imagine I have, I want to write. I have my examples here. I write something like f is null of empty list. I have to. Sorry, I need to. I want to load examples.hs. Yeah, in this case, there's going to be. Oh, yeah, that's a special list, but. Yeah, I need to find. Okay, I'll talk about it later on the Discord, but there is a way in which you can see that the GHC and GHCI work differently. But the main thing is, I mean, you often don't need to write this because inference will tell whether this one should be an integer or not. Sometimes when you write in GHC, you need to be a bit more specific, and you don't have to do it in the interpreter because it has some rules to say, well, you know, if somebody's writing 1 plus 2, I want to get 3 back. I don't want to say, oh, I don't know what type of number you are talking about. But I could also be more explicit and say one float plus 2 is, you know, 3 or whatever. So that's all I had about type defaulting. Yep. If there are questions about this, cool. So yeah, another thing I've seen, and that might be a bit more a stylistic thing, is that I've seen quite some people, which I guess they come from other languages, where you write these things. So you essentially start by pattern matching. Right here, something like undefined. So I have here some examples of this case. So something you need to remember is that in Haskell, you almost never start a function with a case. That would be like the typical thing to do if you do a Scala, for example, where you do match X. But in Haskell, we have this other possibility, which is just pattern matching at the beginning. So yeah, that's just a reminder that that's how you often write these kind of things in Haskell. So you tend to pattern match. You have to duplicate the name of the function, but that's not how you often do this. Something which it's also interested on this idea is that, okay, where would you have to write things? So imagine I'm having a map, and here I want to pattern match on the function I'm calling map with. So in principle, I really need to pattern match here. I don't know, case of true something and a case of false something. So this will tell me, oh, use something different. So I have also something called hlint install, which tells me how to write things better. So I have something like this. So I say my G is this. By the way, I don't know if you also have seen this or not. In Haskell, we actually have curly braces and semicolons. So if you sometimes want to write something which should go in several lines, but you want to write just in one line, you can use braces and semicolons to separate these things. So this is something useful, especially when you are writing in the interpreter and you would need to write several lines. You can write all of them like this. That's not important. The thing is, here I'm essentially pattern matching only to the structures these things, and I'm doing this in an anonymous function. And because people don't like this, we like to directly do this. There is an extension called lambda case. So I can write here instead of this. Well, I need to write here my extension. So you enable extensions. I write in the name of the extension there. I can write here slash case, so lambda case directly. So if the same idea that you don't do this, you don't define a function and then directly pattern match, you can do this if you have an anonymous function by writing lambda case, and then I wrote it like this, but of course you can also write it in several lines, which might look a bit more familiar to you. So I would write something like this. So these are all different ways to pattern match. My point here being that really in Haskell, this is an idiomatic. People pattern match like this directly on the value, and if you have an anonymous function, you actually tend to write something like this, in which you write lambda case, and that means take an argument and pattern matching it directly. Cool. So questions about this? As I said, this is mostly a stylistic thing. I would actually would enjoy knowing your feelings about Haskell layout rules. So the way you need to indent things and so on. I mean, because it's not indentation like Python. It's these rules where you think you need to start on semicolon and things like this. So I'm actually I know that people which are complete beginners to programming struggle with this, and I can see why. And I would actually would like to know your feelings. Being most of you being already experienced developers, how do you feel about these weird rules and so on? Yeah. Oh, somebody says I wish every language looked like skiing. Yeah, that would be awesome. I'm actually I'm so I mean I'm secretly in love with Lisp. So I like Haskell, but I also think like, oh, I should learn Clojure or Racket to do all this macro madness. And I recently actually 2 days ago saw a presentation from David Christensen, which is working on a language which is has typing like in Haskell, but also macros, and they work well together. So it's I mean it's exciting to see what they figure out in that arena. Okay, let's see what's the rest. Oh yeah, something which I found great. I mean, there was a discussion on where folder and fold-L coincide, and by the way, that's been great because that's part of like a, let's say, many of you have found little errata in the book, like like a parenthesis which should be another thing, or maybe a quote which shouldn't be there. But this is actually something which I would, yeah, I would admit it was uh, kind of wrong in the thing, or well. I mean, rereading it, I think it's wrong what it stated in the book. So million thanks to Kartik and Ouchdad. I guess that's how I need to read those handles, which actually they made crystallize what I wanted to say. So that was all about being associative and commutative, and you actually need both for this. So I just wanted to mention for everybody, because maybe the conversation might have gotten a bit complicated, and a bit of what we what they actually found as the summary of everything. So I'm really grateful for this, and I just wanted to talk a bit about this. So uh, so what the idea is that essentially foldar starts by the end, puts the element, so the initial element, and then goes back until the start of the list by doing the operations. Fold-L does it in the other way, to start with the initial element, and it sort of consumes from the beginning to the end. That's roughly the idea of the difference from foldar and fold-L. And if because somebody mentioned about the names, essentially fold is a generic name for something which is folding a data structure. The book talks about it later when it goes to chapter about attribute grammars, what a fold is, but essentially it's like this operation of traversing a data structure and doing something on each step. And then for list you have like left to right, so that's the L, and right to left, so that's what R comes from. And then there is also fold R1 and fold L1, which are the versions which require at least one element and don't take an initial element because they start with the first one, which people often call this a reduce, because in many languages, including like a common Lisp, this is called a reduce operation. So the question we had, and the question that the book asks is, okay, when it's the same to go in one direction and the other. I mean, it's clear that for some operations like I don't know, subtraction, it's not the same to start on one go and then sort of do subtraction here and then there and then bigger than started with the other thing, because in general, you know, 3 minus 2 minus 1 is not the same. So, you know, like, follow. So the question was, where are the same? And I said there are many questions. There are many answers that you could say. Well, if the way you fold always returns the same constant result, then it doesn't matter whether you do it in one way or the other. You will always get the same constant thing. But we want to get, you know, a bit nicer results. So there are actually two interesting cases in which they coincide. So one, and I have here, so one possibility is that F is associative and F is what we call, and the E, so additional element is what we call the neutral element, the identity element, something which doesn't change the value. So essentially like plus it being the operation, which is an associative operation, and 0 being the E, which is the neutral element, because whatever plus 0, 0 plus whatever, it's going to be whatever to give it. So that's important. This E cannot be any E. It has to be specifically the neutral element. And if this is the case, commutativity is not involved. These two things coincide, and the idea of the proof is essentially, I mean, this is just a rough idea of how I think that, actually I think Kartik came up with actual mathematical proofs of this, but the rough idea is like, well, if you start with this from Foldable, the E here doesn't matter, so I can remove it. Then by associativity, they can reswap all the parentheses, and then I can add my E at the end, which wouldn't matter either. And that's essentially what it's produced by Foldar. So that's one possibility. The second possibility is that F is commutative, and the thing is that you also need associativity. So for some reason, I think when I always assumed that F was associative, but the book is actually not clear on this. It says F has to be commutative, but it has to be both commutative and associative. And in that case, actually, if your operation is the same, you can do it for any y you want. So not same y, so this should be any y. So you either don't care about commutativity, but then your E has to be the neutral element, or you have associative and commutative, and then essentially the idea, and I haven't, that's again, the idea of the proof is that you can go and reswap, and the Y can be sort of always moved because of commutativity to the other way. Then you reswap by associativity, then you move the Y, you swap again by commutativity, you reswap parentheses by associativity. And at the end of the day, you can write something, you can go back to this, which would be produced by Folder. So yeah, so those, hopefully that will sort of give you an idea of what you have here. And yeah, so the typical example of an operation like this is going to be plus and 0, and this doesn't matter what you choose because plus is both cumulative and associative. But you know, there are cases and of operation which are cumulative but not associative, and in that case, none of these things will hold. But that was just, you know, I thought revisiting this, because this was a long discussion in the Discord, would be quite nice. Cool. So let's move on to some other things. So another thing which came out is this foldable version using list. So foldable is a type class, which is essentially a generalization of these are things which can be fold. So things which have a folder. That's what foldable things are. And there are essentially things which you can sort of, you can imagine like being able to summarize. So a list, if you give an operation which apply every 2 elements, can be essentially be summarized as one element, summarized. But this can happen also with a tree. So you can like put things together from bottom up and then summarize, like going each two elements and so on. So applying these operations. So many things are foldable. Yeah, almost everything which you can think of being a container of stuff, it's foldable. So you can apply a folder operation on them. So you say how to summarize two of the elements, and it goes on. So there is like some things. If you so you can imagine like length having a type which is like being list of a to int. So like really length being of type list of a to int, and many of these operations. But actually, and this was the case when the book was written, which is I think what makes this extra weird. But at some point it decided to sort of export, instead of the specific version for list, which is what Haskell has been doing for ages, they decided to export the generic version for foldable. So now, when it used to be the case that when you use length, you use the list operation, and you have to import the special, you need to import data.foldable to bring the generic versions, and now the thing has been reversed. So by default, the Prelude, the standard library, exports the foldable versions, yeah. So that's you suddenly see foldable everywhere. So things like null, for example, also work for foldables, because for every sort of foldable structure, you can define a notion of being empty. And that's I mean, I like it because it gives you, like, if you know the listings, you suddenly know a lot of things for many of the data structures. So you have a tree, and then you can ask, okay, is this empty? Well, I just use null instead. Yeah. So what I would recommend right now, actually, for while you're learning, is that you actually don't think too much about foldable until later. When you write code, this is not a bigger code. This is not an issue, because, as I say, usually type inference kicks in, and then it knows whether this null is for list or for gist or whatever. So my recommendation is that you do the following: you do tree type plus d of null, and that essentially it's a trick which says apply some default rules to make things more understandable for beginners, some defaulting rules. So so that's my so I think that makes things much simpler to understand than having the foldable everywhere. So but that's essentially where things are coming from. So right now, the beginning, just use .t plus d to get the types, or look at the types in data.old list, which are the old versions. Once you get but the good thing is that you are learning now a lot about list, and this will actually grow on you, and you will be able to use many of these things in other data structures which are foldable, which are, as I say, most of the container things, so like hash sets and trees, and all of these are already foldable. Good. So that's about foldable and list, and what's the relation between them. Of course, I mean, by the way, you can do something like info foldable and figure out what many things are foldable right now, and these are all the things given for you if you are foldable. So you get foldar, holdel, null, length, element, maximum, sum, a lot of these things. Cool. So okay, I don't know if there are questions about foldable lists. Well, just write questions as they pop in your mind, or either on the chat or the Q&A. Okay. Now something that also have rises is this discussion about new type, and it actually came because I think somebody wrote data person equals person string, I don't know, and then hlint, the linter, the thing would tell you how to write, good, and still an idiomatic Haskell code says, oh, please, use new type instead of data. So I guess if you see a red line under your code, just go and do whatever it tells you. I don't know, that works for me. So what is the difference between data, new type, and what's the difference between writing this and this? And also what's the difference between writing, so let's call it 1 and 2, so I don't get a problem. So what's the difference between writing this and this? So let's start with the basic thing. So you can essentially separate the way you create new names for types in Haskell in two different things. So you have data and new type, and those two, I can write sort of a beautiful ASCII art again, create a new type. So a new type, starts existence, whatever it's born, whatever you want to say. So data and new type create a new type. So and this new type is different from any other type. So new person 1 and person 2 are new types, and they are different from any other person. Now type creates an alias. That means that's just a different name from something which already exists. So if I have here the type person equals string, and you can see there is no name of constructor because we are just saying person 1 is a new name from string, and it doesn't matter whether you use person 4 or string. These are exactly the same. These are aliases. So these are two names for the same thing. So you often use type to have names for big things. So something which often happens is that in a big applications that you have this, you learn about this later, but you have this thing called monotransformers, and then you need to define a big type, which you say, oh, my application has a reader T of configuration, and then it has a state T of whatever DB, and then it has a maybe T of IO. I don't know. But that's the point being, this is a big thing. I don't want to write it over and over, so I define an alias for this. But this thing is exactly as if I wrote this, and this is actually what the compiler does. It every time it says a type synonym, it expands it to the original version, and then it goes on with checking. So that's the difference between data new type, which create a new type, and type. Now, what's the difference between data and new type? So in both cases, they create a new type, and if you remember, algebraic data types in Haskell always are defined by let me make this into a comment so I don't get syntactic errors. They always are defined by one or more constructors which hold one or more pieces of data. So I could have here person 1b, which has an int. I don't know. But I cannot do that with person 1, person 2b with an int. That's wrong. I should get an error, which I don't get. Oh, that's very weird. But this will be an error. It will eventually be an error. Okay, my editor integration stopped working. Good, but okay. Bear with me, this is an error. New type is like a way to form data which only allows one constructor with one value inside. And so why do you have both things? So to understand why, you need to know a bit about how values are defined in memory, how they live in memory in Haskell. So you can imagine that in general, a value in Haskell is defined in memory. So that's how it actually exists in memory. It's a pointer. Okay, there are always pointers in Haskell when it's memory, but each value is going to be like a tag, which says what constructor we are choosing, and then the value of field 1, field 2, and so on. So that's essentially how these things look in memory. Moreover, each of these fields is actually a pointer to the value of that field. So you will have here like another beautiful square for this, and another beautiful square for this, which are the data of each field. So those are how things look in memory. Now that's okay, but it's actually sometimes it's very expensive. And in particular, if you have only one field and only one constructor, you can get away with way less because you don't need a tag. You know, there is only one constructor. You don't need a pointer because you know what you know that's gonna be there. So you can just get away without this and then just have the value of the field directly without this tag, without this pointer. So that's what new type is, and that's like an optimization. And the thing is maybe now it's not clear, now it's not obvious to you, but this is actually very common in Haskell to define like a new name for a type, and that's usually to distinguish things which have the same sort of internal like data, but they're actually different notions. So imagine I have like, my favorite example is you can have ages, and they are usually like int, and you can have temperatures, and they are also given by ints, or yeah, let's assume it's given by int, but you never want to mix those two. So you don't want to add an age with a temperature. It doesn't make any sense, or the other way around. So what you do is you define a new type, which is different from others. So remember that every time you have data or new type, this type is different from others. I would say, okay, like these two things are going to be integers, but I want to be able to distinguish them, and I want the compiler to track whether this thing is an age or this thing is a temperature. And you know, people do this quite often. So once you get to the database chapter, you will learn about persistent, and one of the thing with persistent is it has different types, different new types for identifiers for each table in a database. So you know that you never mix up, you know, an identifier for a group, an identifier for a person, an identifier for an order, just because they all happen to be int 64. So this new type is often used quite often, and because this is quite often, and you have this special extra optimization, you know, it essentially asks you to do this. Of course, the question is why shouldn't the compiler just apply this thing to the data, and you have to be new type? And the reason for this is more debatable. So of course it could do it in general, but the problem is that, you know, what happens with forward compatibility. So if you have a data, you are essentially saying, I might add new constructors in the future. So that means that you know, you want to keep the tag because maybe you want to add new tags in the future. If you have new type, you're really promising that you will never do this, so the compiler can do more optimization. So it's like you are promising that you will never, you will only use one constructor with one field. You know, again, I always find it debatable. So maybe we shouldn't have new type, and it should be a form of data or an optimization performed by the compiler. I don't know, but that's how it is in Haskell right now. New type, it's for the cases in which you want to define, you want to just wrap an existing type, but you want it to give it a distinct identity because you don't want to mix with different things. And as I say, just think of ages and temperatures, or I don't know, ages and IDs from a database. They are both integers, but you don't want to mix them up. So Haskell can help you with that. Good. Yeah. Yeah. Another thing is something about the direction of the fat arrow. So that's how most people will read this, something like fat arrow or big arrow. So oh yeah, that's something. Yeah, that's great. The depot, thanks for reminding me. Yeah, that's also these new types is great because when you have type classes, as you know, type classes need to be unique for every type. So if you suddenly want to have like a type, which so you need to have the same type but a different type class instance. What you do is you wrap it in a new type, and then you can assign it a different type class instance because now it's a new type. So that's also a trick you often play. So I don't know. For example, you can think booleans can be combined into different ways with R and with or, and each of them you can assign to new types, and they are called any and all, and assign them different instances. Something like this. Yeah. So yeah, as you tell us, yeah. So Idris, which is a language which sort of it's it looks very much like Haskell, but it has a more powerful type system. They have named instances, so you can have different instances with different names. There is also a lot of discussion whether they should be in Haskell. There are big names saying, well, we shouldn't have this. That's how it does. But in other languages which have more powerful type system, maybe this makes sense. So that's usually called a coherence problem. So if you read about this, you know what it means. So it means the idea of if you have one type, can I give it two different class instances to the same type? Haskell says no, so that the trick is wrap it in a new type, and then you can assign a new one. So yeah, great. Thanks, thanks folks for reminding me. That's actually another useful way to use new type. Yeah, so let's move on to the direction of the arrow in classes and functions. So you might have seen that, for example, if you have something like lm, this has something like eqa, a to list of a to bool. But if I'm defining a new class, let's call it eq prime, sorry. So you have things like this, and then you have something like instance or a. So you have fat arrows in different things, and the thing is, even though these three things have the same direction, many people, and I think it's worth thinking of them sometimes in a reverse thing. So but actually they just mean three related but different things. So if you have a thing in a function, that means is like a constraint or a requisite on A. If you have it in a class, so that you're defining a superclass, that's actually the same thing. That's also a requisite on A. So that essentially meaning or a, it's a requisite, but also people sometimes read it in the other direction, because that means that if you have an OR A, you will always have an EQA. So it's like by writing this, you ensure that every time you have something which is ordered, you can also make them equal, because you can check the ordering and check if they are equal. So some people like to write it like this, thinking on the reverse idea. And in the case of an instance, that means you will have an instance for this if and only if you have an instance for this. So actually you may want to write something like this. So there is an OR instance for list of A if and only if there is an OR instance for A. So I can order a list of things if and only if I can order the elements inside. And I like to write like if and only if, because it's weird. It's something. So if you think of how the compiler works, what it will say is, okay, I want to check whether a list of ints can be ordered, and then I sort of want to check. So you go like in this direction. You want to check whether the ints can be ordered. On the other hand, you know that if ints can be ordered, then so you're reading it in this direction, then list of ints can be ordered. So I just want to point out that this direction sometimes can be misleading. In theory, that's like a then, but in this case, the then it's kind of it doesn't. So if I write this, this doesn't mean that if I have an EQ instance, then I have an OR instance, but actually the reverse thing. That means that if I have an OR instance, then I have an EQ instance, and I need to satisfy this. Here, it's like an if and only if. You can think in that direction, in that direction. And by the way, if you look at other language based on Haskell, which is called pure script, imagine like Haskell, which is a script that compiles to JavaScript, they decided to do it in this way because the reading is more in that direction. So yeah, I wanted to point out that there I always like to teach, like, you know, if you have a fat arrow, there are actually 3 readings for this, depending on whether you're in an element, class, or instance, and the direction is just, you know, don't think of reading it as then. Just, you know, try to learn what they mean in each case. So that's for fat arrows. Good. And then the last, so that's what I gather from the discussion. But then the depot asked me maybe I should talk something about laziness in practice. So of course there is a chapter about laziness. So I mean, you might be wondering, is this a big deal? So why do we take so much time talking about it? So to be honest, laziness is something you often don't think about. So I don't think I have had problems with the laziness which haven't been solved by essentially thinking a bit about whether I need foldar or foldl, which is the main difference. So that's what the book discusses and so on. So in practice, you know, laziness doesn't arise, and I think there is a reason for this. So laziness is very useful to define operations like and. So I think you might know that if I define and, then this is lazy because I only need to check the first argument. So this is something like this. That's how I define and. So I only need to check the first argument. Otherwise, and if it's false, then I don't even have to check the second argument. I just, you know, go and return it. So I never have to force it. So these kind of things are very, very useful. So of course you want your and to be short-circuited. You know, that's why everybody, when they write C or Java, they write and not the normal and. This also happens, for example, with map. You want your map sort of to be streamy in the sense of it only produces the new results as it needs to. So you're sort of getting what in other languages you need to bring some streaming library. You are getting this for free in Haskell. So all your maps are like more like streams of data. You only need to produce the next element of the map you need to when you pull it. So I think laziness is great for these primitives, but you don't often write these primitives. You often write the code which uses the primitives, and in that case, you're sort of using laziness. But then most of the code you write is just code which is going to be executed. You don't often write code thinking on laziness because that's my experience. You often just write the code you want to execute. So that's my point of view. The only place where I found laziness to be incredibly useful, and I actually think about it operationally, is when I can define something like an infinite thing instead of and then sort of filtering. So sometimes it's easier to define an infinite things and filter and then take the first 100 elements instead of actually writing a function which keeps track of this kind of thing. So in the case of say things which somehow I can define it as infinite things, and maybe you think, oh, you know, this guy's weird. How would I ever define this? So so for example, if you have like a search problem, like you want to search everything and then get the first solution, and you know there is a solution, but you just want to write quick and dirty code which goes around the thing and gets you the first solution. You know that you can sort of write an infinite list, but by only getting the head of this list, you will not force the entire list. So this is the kind of like search problem. That's the place where I often use like infinite structure for what you need laziness. The depot is asking what about accidental space leaks. That seems like a trap for beginners. So I actually think it's of course you need to know what it is about, but maybe it's just because I've been writing Haskell for a longer time. I don't often get into that trap, but I haven't found this to be so problematic as maybe discussing space leaks make it sound. The problem is, of course, that space leaks, if you don't know what's going on and you suddenly see your memory racing and you're a beginner, you might be wondering you're doing something wrong, and it's hard to explain this without explaining laziness. That's why I think it's very important for people to know what laziness is. But as I said, I don't often run on accidental space leaks if I follow two general rules, which is like essentially use foldel instead of foldar. That's often a good thing. And the second being use containers, strict containers. So if you go to the containers library, you will see that they often have strict containers. So, and they often are better for this space leaks. So I mean, one problem where you might run into accidental space leak is you are putting things on a map, on a hash map or something like this. And of course, when you insert, if you don't force this, then there is actually no insertion. There is just, you're just building this bigger and bigger list task which says, oh, you will have to insert it and you will have to insert this. And then often it's not that you have a space leak, is that suddenly when you want to search something on the hash map, then suddenly on this insertion have to be executed. So it looks like insertion is free, but that's because you are just postponing it. And then when you want to do the first lookup, and you can imagine, this being on a web service, and then suddenly your first customer experiences a big delay and then not the others. That's okay. So, oh yeah. So Hackage mentions that also maybe avoiding having an accumulator when writing recursive functions, because the accumulator times will keep growing. Of course, that's all very. I mean, the problem with this is that it's very hard to say things. In general, if you have an accumulator, you might think about forcing it, as we do in Foldel and using Foldel prime. But the thing is that this is not always the right answer, because that also depends on the way in which you use the result. Because if the way you fold like generates, let's say, the top level constructor, and then the way you use this only requires this top level constructor, if you force, you're doing work which is unneeded. So forcing can get you into doing work which is unneeded, or potentially infinite, of course, if you have like a non-terminating thing or an infinite thing. So it's hard. It's hard to say that really. You have to trust me in this, but I read Haskell code and I never ever think about laziness, except when I do infinite things. So be aware of this. Try to use containers which are strict. But apart from that, I would suggest don't think too much about it at this point. Most of the times, like, you will have more performance problem coming from maybe using a list where you needed to use another data structure, or having a big monotransformer which introduces extra overhead because of the big dependency chains and things like this. So that gets to the end of my list. I don't know if there are any more questions. So there's give a few minutes for people to think. I mean, Discord's still open, so we can talk about it. Just for everybody to be on the same page while people think for more questions, I propose, and I think most people had set like a heads up to maybe we should, move. So in principle, this was a session for chapters 1 to 6, but I think that, many people just were able to go to chapter 5 or 4. So maybe we can start next session to be chapters 6, 7, 8, 9, which is also great because 6 and 7 are about monads, which is of course these big things when learning Haskell. Yeah. So I think that's nice, and I'm all for if we see that we need to go slower. I'm also all if the organizers agree to maybe slow the pace a bit and maybe have take an extra month or something like this. So, but in principle, next day that's gonna be the M word day where we discuss about all the nuances about monads, and hopefully most things will be resolved in the chat as we've been doing here. And the Discord chat, but yeah, I'll just talk a bit in a month or so. Okay, I see no more questions. Yeah. Oh, thank you. That's not a question, but yeah, you're welcome.